The drone holds station at 1,200 meters. Below it, a single ribbon of grey road cuts through farmland somewhere in eastern Ukraine. And on that road, a column of Russian armor is moving north. 6 vehicles, then 8. The camera tracks them, and something about the picture is wrong. They are not bunched. Between each vehicle sits an open stretch of empty asphalt, long, deliberate, repeated. The analyst pauses the frame, drops a measuring line across the gap, and reads the number twice to be sure. Roughly 80 meters. Every vehicle in the line is holding 80 meters of distance from the one in front of it. That is not a traffic pattern. That is a decision. The question is what they were so afraid of. A retention_checkpoint, 0 o'clock hook. The answer is written into 3 years of wreckage. This investigation takes one unremarkable transit clip. A column on a road, nothing burning, no strike, no drama, and reads it the way a forensic analyst reads a fingerprint, because the spacing on that road is a fingerprint. It encodes how Russia learned to move under the most watched sky in the history of warfare, and it points to the exact place on that road where all of it still falls apart. Retention_checkpoint 030 hook resolution tease. Start with the sky. By the spring of 2026, the airspace over the contact line in Ukraine is not airspace in any sense a 20th century soldier would recognize. It is a contested ceiling, layered from the ground up. Commercial quadcopters at 50 meters, first-person view strike drones racing at 120 kilometers an hour at treetop height, fixed-wing reconnaissance aircraft loitering at 1 to 3,000 meters, and above all of it, the satellites. Anything that moves on the ground in daylight is on average being watched by something. The Ukrainian platform that filmed this column belongs to that loitering reconnaissance layer, the class of aircraft built for endurance and optics rather than speed, the kind that can hold a single point of interest for hours and stream what it sees to an analyst far behind the line. Movement in this environment is the hardest thing an army does. A dug-in position can be hidden, hardened, camouflaged, but the moment armor takes to a road, it becomes the easiest target on the battlefield. A line of hot engines on a fixed, predictable path, unable to maneuver, channelized by the very road that lets it move at all. Every mechanized warfare doctrine written before 2022 assumed the side with air superiority controlled that risk. In Ukraine, neither side holds air superiority in the traditional sense. What they have instead is mutual, persistent, cheap aerial observation. And that single fact has rewritten the rules of the road march from the ground up. To understand why 80 meters matters, you have to go back to the road north of Kiev. In the last days of February 2022 and into the first week of March, a Russian armored column estimated at 64 kilometers in length, roughly 40 miles, formed up along the approaches to the capital. The world saw it because Maxar Technologies released the satellite imagery around the 1st of March. Frame after frame of vehicles parked nose to tail, some stationary for days. The popular memory of that convoy is that it ran out of fuel and food and simply ground to a halt. That is part of the story. But the part the dispersion record makes uncomfortable is this. Even when it was moving, that column was packed at intervals a peacetime road march would recognize. Vehicles separated by a few dozen meters, sometimes less, bumper to bumper at the choke points. It was a formation built for a war that did not arrive. The same week, the failed air assault on Antonov Airport at Hostomel had already shown that the opening plan was unraveling. The convoy was the consequence, frozen on a highway in the open, and it paid. Bayraktar TB2 drones, then still novel, picked at the head and tail of stalled segments. Ukrainian artillery walked fire down the line, ambush teams hit the front, blocked the rear, and trapped what was between. When vehicles sit a few meters apart, a single burning tank is not one loss. The fire spreads, ammunition cooks off and throws fragments and turret rings into whatever is beside it. The wreck slews across the road, and the column behind it cannot pass. One good strike could disable 5 vehicles by disabling one. That is the lesson Russia carried out of 2022, written in scorched hulls along a single highway and catalogued, vehicle by vehicle, by the open-source loss tracking project Oryx, run by the Dutch analysts Steinmitzer and Joost Olymans, which to this day counts only what can be visually confirmed in photographs and video, and whose Russian armor tally has run into the thousands, which brings us back to the clip and to the first problem the analyst faced. You cannot simply count pixels between two vehicles and call it a distance. The drone's camera is not pointing straight down, it is looking at an angle, and an oblique view compresses distance. Objects farther from the lens appear closer together than they truly are. Measure carelessly and an 80-meter gap reads as 50. The fix is photogrammetry's oldest trick. Find something in the frame whose real size you already know. A Russian main battle tank, a T-72 or T-90 hull, runs a little under 7 meters long, a standard military truck around 7 to 8. Ground sample distance, the real-world size each pixel represents, is set by the camera's focal length and the drone's altitude. On an oblique frame it changes across the image, so the analyst used a vehicle of known length lying in the same plane as the gap as a local ruler, corrected for the perspective, and only then read the spacing. Only then does the measurement hold. I went back through hours of comparable footage to check the number against itself. Across multiple passes, on the straight sections where the geometry is cleanest, the interval held. Not exactly 80 meters every time, but clustered tightly around it, 70 here, 90 there, the kind of scatter you expect from human drivers holding a target distance by eye rather than by instrument. That consistency is the whole point. Random spacing is what breakdowns produce. A tight cluster around a single value is what a rule produces. So the column was following a rule. The investigation could have stopped there, with a tidy finding about Russian movement discipline. It did not stop there, because when the analyst extended the measurement to the back third of the column, one pair of vehicles broke the pattern completely. Retention_checkpoint, approximately 7 o'clock micro final/cliffhanger, Band C. Set the anomaly aside for a moment. We will come back to those two vehicles. First, the number itself. Why 80? Why not 40 or 150? The answer is a calculation about damage, and it has three parts. The first part is the warhead. The dominant threat to a moving column today is not the artillery shell or the ambush. It is the FPV drone, a first-person view quadcopter derived from racing hardware, carrying a shaped charge or a fragmentation warhead, typically in the 1 to 2.5 kilogram range, flown by an operator in goggles who steers it into the target by hand. Above it sits the loitering munition, the Russian Zala Lancet for instance, with a warhead of roughly 3 kilograms, able to circle and wait before diving. Neither weapon carries a large lethal radius against armor. To destroy a tank, an FPV usually has to hit it on the thin top plate, the engine deck, the turret roof. The threat is precision, not blast. The second part is what happens after the hit. When a vehicle is struck and its own ammunition begins to cook off, it does not simply stop, it becomes a hazard to everything near it. A fountain of fragments, a fire that can run for minutes, and on a road a wreck that may swing sideways and block the lane. At a few meters spacing, the vehicle behind is inside that hazard. At 80 meters it is outside it. The fire does not jump the gap. The fragments fall short. The wreck can be driven around, or the following vehicles have room to brake, reverse, and route around the obstacle rather than piling into it. The third part is the economics of the attack, and here is where 80 meters does its real work. An FPV drone is a single-use weapon with a single target. One drone, one vehicle at best. A tight column lets one operator or one loitering munition with a wide fragmentation pattern threaten several vehicles in a single pass. The math favors the attacker. Spread the column to 80 meters and that leverage collapses. Now each vehicle is its own separate problem. The attacker needs a drone per target, an operator per target, a flight per target, and every one of those flights is a chance for the vehicle to accelerate out of the engagement zone, for a jammer to break the radio link, for the drone to simply miss. Dispersion does not make any single vehicle safer from a direct hit. It makes the column as a whole far more expensive to destroy. What is striking about this adaptation is how cheap it is. It costs nothing. No new vehicle, no new weapon, no new factory. Just a number in a driver's head and the discipline to hold it. and yet it quietly rewrites the most basic act of an army. The road march has been redesigned not by a general's signature so much as by accumulated, distributed survival. The men who learnt it the hard way, and the ones who did not learn it are entries in Oryx's database. There is a second pressure behind the gap, and it sharpens everything. Through 2024 and 2025, a new class of FPV spread along the front, the fiber optic drone, trailing a hair-thin spool of optical cable that can run 10 or even 20 kilometers, carrying its video and control signal down the glass instead of through the air. A fiber drone cannot be jammed. The electronic warfare bubble that used to be a vehicle's last line of defense, the dome of radio noise that severs an FPV's link in the final seconds, does nothing against a signal traveling through a wire. So one of the two ways a column used to survive a tight formation, jamming the swarm before it arrived, has been quietly removed. That leaves the other way, physical separation. 80 meters of empty road. The real surprise here is not the spacing itself. Planners have understood dispersion since the first aircraft flew over a trench. It is how completely the threat has inverted. For a century you dispersed against artillery and airstrikes, against an enemy that was expensive, scarce and high above you. Now you disperse against a $400 quadcopter flown by a conscript with a controller, an enemy that is cheap, abundant and at eye level. By 2025, both sides were fielding FPVs by the hundreds of thousands. 20th century air power has been replaced by a swarm you can order from a hobbyist supplier, and the 80-meter gap is the ground force's answer to it. The doctrine then was clear, the logic airtight. On open road, 80 meters made this column a hard, dispersed, expensive target no single drone could unravel, which raises the only question that mattered to the people watching the feed. Where does it stop being open road? Our attention _checkpoint, approximately 14 o'clock mid-roll hook / micro final. Here is the take that will probably draw fire. The popular picture of the Russian army as a doctrinally frozen brute force machine that learns nothing is, on this specific question, out of date. On movement discipline, on the unglamorous, distributed, bottom-up business of not dying on a road, they have adapted faster than several Western armies might have, precisely because Western armies have not been forced to. No NATO ground force has driven a column under 3 years of continuous drone observation. The 80-meter gap is not evidence of Russian brilliance, it is evidence of Russian attrition. But a force that adapts under attrition is not the force the early headlines described. So here is a genuine question, and we read the comments. Is 80 meters the mark of a force that learned, or a force that was beaten into learning? One burning column at a time. Those are not the same thing, and which one you believe changes how you read everything that comes next, because a column cannot hold 80 meters everywhere. The interval is a luxury of open ground, and open ground runs out. It runs out at bridges, where a single span forces the entire column down to one lane and one vehicle at a time. Nose to tail, the exact geometry the dispersion was built to escape. It runs out in defiles, cuts between high ground, causeways across marsh, the narrow approaches to a river crossing, where there is physically nowhere to spread, and it runs out at the entrance to any built-up area, where the road narrows, the walls close in, and 80 meters compresses to 10. At every one of these points the column rebunches. For the minutes it takes to thread the gap it is, once again, a 2022 convoy, and every drone operator on the other side knows it. The analyst watching this feed knew it too, and that produced the third problem. A reconnaissance drone sees a column now. It cannot see the future. To know whether the column was about to be exposed, the analyst had to reconstruct its route, match the visible stretch of road against mapping, fix the heading, and project forward to the next forced constriction. The terrain in the clip was running toward a river line. Somewhere ahead, off the edge of the frame, was a crossing. And a crossing meant the 80 meters would have to fold, and those two vehicles at the back of the column, the pair that broke the pattern, riding close while everyone ahead held the gap. There are 3 readings, and the footage does not settle between them cleanly. The first is mechanical, one vehicle under tow or nursing a fault, the second shepherding it, a recovery pair that cannot keep the interval because one of them can barely keep moving. The second is command, a command vehicle and its escort, deliberately paired for communication and protection, accepting the local risk for the sake of control. The third is the simplest and the most telling, a discipline lapse, two drivers who let the gap close because they were tired, or new, or because the rule lives in training and training is never uniform across an army of conscripts. That pair is the detail that stuck with me. Everything else in the frame is a system performing correctly, a learned, distributed, almost machine-like discipline, and then two vehicles riding close, a single flaw in the lattice. On open road it costs them nothing. At the crossing ahead, riding that close, it could cost them both. The column moved on toward the river it could not yet see, holding its 80 meters on the open stretch, the close pair trailing at the back. The clip runs out before the crossing. We do not see what happened at the bridge, but the OSINT record of what happens to columns at bridges is not ambiguous, and it tells you exactly what that last stretch of open road was worth. The retention_checkpoint, approximately 21 o'clock microfinal.
There is one more number we pulled from this clip and left out for length. The column's average speed calculated from how far the lead vehicle traveled between two time-stamped frames, and what that speed implies about whether the unit, still unnamed in any public source, expected contact or was simply transiting.
It changes how you read the whole sequence. If you want that measurement broken down in a follow-up, drop the word speed in the comments and we will build it. What the OSINT record has established about choke points over 3 years is consistent enough to function as a rule of its own. The most watched single points on the entire front are the crossings. Every standing bridge over the Dnipro and its tributaries, every pontoon thrown across a river under fire, has been a magnet for loitering munitions and FPV drones, precisely because the enemy knows the column must compress to use it. Russia has answered with smokescreens, with electronic warfare bubbles meant to sever the drone link at the span, with crossings attempted at night, with decoy bridges built to draw the first strike. Each answer works sometimes. None of them restores the 80 meters. The gap is the defense. The crossing is the one place the defense cannot exist. The clip says one thing: a column on a road, nothing burning, no strike, no drama, and inside that mundane footage the entire arc of the war is readable. 3 years ago, Russian armor drove bumper to bumper into the most watched sky in history and was catalogued, hull by hull, for it. Today, the same army holds 80 meters by reflex, having learned the only way armies ever learn. And still, at every river it has to cross, the lesson runs out. The gap folds, and for a few minutes the column is back on the road to Kiev. That is what this war actually looks like. Not one side outsmarting the other, but both adapting in real time to a sky that no longer belongs to anyone, where a $400 drone decides how the most expensive vehicles are allowed to move. We measure these clips frame by frame because that is where the war changes, not in the headlines, but in the 80 meters of empty road a driver now leaves without being told. If you want to see how the next adaptation gets read out of the next clip, that is what this channel does. Retention_checkpoint, last 60s payoff plus open loop, trom or.